So, hello everybody. My name is Martin Sumera and I am lead Android developer at Futured. Welcome to our presentation about Compose and its usage beyond Android development. During this talk, you can expect that you will learn something about Compose tools outside of Jetpack Compose world. Also, a little bit about Compose internals and some example of how to use these tools to build simple app. What you should not expect is some deep dive into setup of these projects, a lot of technical details. I will try to stay on the surface in order to keep it simple. And of course, you should not expect a Spanish Inquisition, because nobody expects a Spanish Inquisition. And I know that's a bad joke, and it will start to make sense after a few slides. Anyway, here are some prerequisites of these talks. I believe that listeners should know some basics of Jetpack Compose. They should know how to build simple application, and however, you don't have to be an expert in it. Also, know a little bit about Kotlin multi-platform may be also helpful. So let's start with Jetpack Compose. I believe that it doesn't need an introduction. It's a toolkit for building native UI for Android. And I believe that this was the first public showcase of Jetpack Compose code that we saw. Chad Hayes and Roman Gee created a simple bad jokes counter. As you can see, there is already one bad joke on a counter, so it's mine. So now you understand. But in order to understand the use of Compose outside of Jetpack, we need to understand its architecture. It basically consists of following layers: runtime, UI, animation, foundation, and material. There is also a compiler, and that is definitely important and very interesting part of Compose, but let's not talk about this in this talk, just for the sake of simplicity. And let's move on to discussion about each layer. Compose runtime. I would say that Compose runtime is the most interesting part. It contains all the necessary building blocks to create Compose application, from internal things such as snapshot, recomposer, applier, and all the building blocks that you usually don't see, to visible things such as snapshot, such as remember, mutable states of, and side effects, such as launch effect. Yeah, all these things that you are working with. Runtime contains all the necessary logic to run Compose for UI outside of Jetpack, or even without UI. We will talk about these usages in a few slides. Next layer is UI. This is basic building block for UI development. There you define your own, that you basically define how your UI will work, how it will be drawn, how it will communicate with underlying platform. In case of Jetpack Compose, it will be mainly Canvas, or in some cases, native Android view, thanks to interoperability of the whole system. Next layer is animation. It contains all the things related to animation. So basically, when your components move, it's very probably that you are using something out of this layer. Foundation contains basic building blocks for layouts and for design systems. You will find there all the things that are not related to how exact should things look like, but more like how they should be placed or measured. So basically, when you are building your own design system, you should consider to use Foundation as your base. And the last one is a material. Probably the most notable layer for a lot of developers. Compose mean things like buttons, scaffold, text, and all the things that are part of material library. And yeah, and the material library on the Compose is like the most popular design system built on this foundation. You can find several more, but I think that the material is most popular one. And all these things together creates what we call Jetpack Compose. It's basically a toolkit for creating Android applications. But there is more to it. We can talk about the Compose and Jetpack Compose, and by that we can mean two different things. it's not like it's probably not a big problem for most people, or most people doesn't even know that this problem somehow exists, but a little confusion is already there. Like a lot of job posting are mentioning just Compose as a technology instead of Jetpack Compose. And they mean Jetpack Compose. I know that and you know that. But when I see this, I'm always thinking like, hey, are they building something with just Compose runtime? I'm pretty sure they do not mean that, but I can unsee it. I'm not like 100. I'm not 100% sure what is the correct naming here and what is not. But by Compose, I understand Compose runtime, set of tools for working with tree-like data structures, its snapshot system, and slot tables. And on the other hand, by Jetpack Compose, I understand set of tools for building Android UI. And this discussion existed already back in 2020, 2021, that these things should be named differently, but idea wasn't accepted. And thanks to that, when we are talking about Compose, we can interchangeably mean Jetpack Compose and so on. But Compose is much more. There are multiple libraries that are using Compose runtime or some different parts of Compose as a tool for different kind of things. I selected a few. For example, Glance is for widget development on Android platform. But Redwood and Compose multi-platform are tools for building multi-platform UIs. Mosaic as a tool for building command line application, Molecule and Circle for basically as a tools for handling business logic. And for example, Compose PPT is a tool for creation of presentations. And I will talk about a few of these in a minute. In order to understand how these tools works, you need to understand a little bit about Compose internals. It's a quite complicated topic to fully comprehend, but it's good to know the basics. Few concepts that I would like to talk about are recomposition and nodes. But for more detailed explanation, I recommend you the book Jetpack Compose Internals, when you will find much more details. Or there are a lot of articles on the internet who are explaining these things in a much more deep dive way. But the thing is that you probably won't need these for day-to-day work, but it's always good to know the internals of the system that you are working with. So let's talk about nodes first. One way to look at the Compose is to look at it as a tool for working with tree-like data structures. And node represent an element in this tree. But let's take a look at the following diagram. First, we have data as an input. Data are passed to composable function when they are transformed into tree of nodes, which represents element in a UI. When we will go to declaration of some composable methods, multiple times, you will find a code where the data that are passed to the function and all the modifier collected along the way are transformed into node. And here we can see an example of such node directly from Jetpack Compose code. This is as deep as you can go into any kind of composable function. You will find something like this. And at the end, there is a tree of UI elements which represents current state of the UI. And these nodes are then rendered on the target platform, which may be Android Canvas, Android Views, command line, file, iOS, desktop, basically whatever. Basically anything that can have some kind of tree structure, and we are able to somehow access it with Kotlin. Nodes are representation of hierarchy in the Compose. When some state are changed, then tree is updated and rendered again if necessary. Important thing here is to understand that nodes can represent whatever you need. As I said previously, it may be view, some set of draw commands, or just string. And this is the powerful concept that may be used to implement different things. Next thing to understand is recomposition. And that's something that for most of you won't be basically a new concept. But it's a very important concept for the libraries that I'm going to show you, which are using Compose runtime without UI. Let's imagine a situation where user performs an action. This action changes the state, which notifies snapshot system, and then will cause recomposition of components that are reading from this state. That's pretty straightforward thing for most of the Compose developers. Interesting thing is that it can work even without any other composable objects. So let's take a look at this code. It's doing the very similar thing, but without any other composable function. There is no node emitted internally, but it will still works. We change the counter, then we change the state which notifies snapshot system, and that will cause recomposition of components. In this case, launch effect that are reading from this state. This allows us to use some kind of reactivity as we know it in the context of Compose. And this is a very powerful tool used by several libraries without even need of the Compose nodes. We will take a look at this in a few slides. Let's move on to a few examples and see how they work. First example is a glance. Glance is a tool for creation of widgets and wear tiles in Android system. When we will take a look at the glance code, we will see that the code is almost unrecognizable from the Compose code on the first look. On the second look, however, there are some differences. And let's go to declaration of checkbox, for example, to see them. There we see that checkbox is using glance modifier. And this is the first thing that we will notice as a difference between glance and Jetpack Compose. It uses different implementation of modifier, and it's also using different underlying implementation of UI layer. And by that, I mean different UI layer in the Compose architecture that we saw previously, and also different UI layer as an underlying render output of nodes. And if we will go to declaration again, same way as we did previously, we will find a node, specifically a glance node, which is some kind of different implementation of the same concept used by Jetpack Compose, but adjusted for different needs. And these needs are basically the limitation of glance and widget system on Android. We can use Jetpack Compose nodes because widget system is limited to the set of few allowed views, such as checkbox, button, text, list. And if we would go exploring code even more, that we would end up with this good old Android view, which is inflated and used as an output of a node. So glance is creating views instead of drawing them directly to canvas as Jetpack Compose do. And this is the power of Compose runtime. Almost the same API, but different result. And here you can see the architecture that is used by glance. It is using runtimes, a few modules from UI package, and then it builds its own composable system, which is similar to Jetpack Compose on the surface, but different internally. Now, let's move out of the Android world as I promised and see another example. Mosaic is experimental tool for creation of command line applications. As far as I know, it was created as a showcase of Compose runtime capabilities, and I believe that it's a really great example. Mosaic applications are relatively simple. This code is what you need in order to create a command line application. You are able to add elements like text and similarly to Jetpack Compose, which are then shown as a terminal output. Since you are working this command line interface, the UI capabilities are limited to compared to the canvas. But even there, you are able to use things like a column or row. You are even able to use most of the Compose runtime elements, such as mutable state of, remember, or launch effect. And for example, in this example, we are creating simple counter where counter variable is increased every few seconds. And thanks to ANSI escape codes, which are built directly into Mosaic runtime, cursor is moved back to the start and it re-render the output. But let's take a look at internals. So if we will go to declaration of text, same way as we did before, there we will notice that Mosaic doesn't implement any kind of modifier. Command line interface is much more restricted than UI on a canvas. So only text color, background, and text style are direct parameters. And that is sufficient here. Text internally is implemented as a layout, and when we will take a look at declaration of layout, we will find, again, a node implementation. As we already know, this is node, and it's added to the tree and then rendered. So if we will go exploring again, and we will find how it is implemented. We will find that these nodes are not transferred into some kind of UI elements, but this time it is transformed into string, which is then printed to the console. If we will take a look at architecture, we will see that Mosaic is using only runtime and implements its own version of UI and foundation package. So again, thanks to Compose, we are able to use almost similar API as with Jetpack Compose, but for totally different use case. And next example goes even more far away from traditional use of Jetpack Compose. Molecule is an example of non-UI usage of Compose runtime. It allows you to use reactivity and composability provided by runtime to handle business logic. And let's take a look at example. Here we see the normal Jetpack Compose code. There are a few issues. For example, like the UI layer needs to know about business logic. It somehow also couples UI with storage and forces us to provide some different values for this flow when they are transformed to state, which may not be very clear for us. And these are basically issues that can be easily solved by presenter or view model, when we can use reactive streams such as Aries Java or Kotlin Flow and to combine them. But with reactive streams, there are issues. Yeah, they basically tend to get complicated and hard to read when streams are combined, transferred, mapped, flat map, combined again, and so on. Compose allows us to use reactivity with more readable and imperative manner. Take a look at this example. It looks similar, but there you can see perfectly fine molecule code. On the first look, there is nothing special. This code could be compiled by Jetpack Compose, and it would work. But if you will take a look, you will notice something which is not very usual at the Compose code. A presenter, which is function, and it's marked with composable annotation. Molecule doesn't force us to use some kind of specific presenter or view model. It's using normal composable function very similarly as we would do with Jetpack Compose. If we will take at details, we will notice that flow in this presenter is transformed into state the same way as it was in the Jetpack Compose version. But the thing is that there are no composable functions, which would be emitting some nodes internally. This function returns a sealed class, which represents the UI state. And when I'm thinking about it, I'm not sure what would happen if you would use composable function from Jetpack Compose here, since it's used in different runtime, but it will probably end up with a runtime exception. But let's get back to example. So this is the place where recomposition, even without nodes, starts to make sense. We can use states, parameters, flows, and create reactive logic of the app based on the Compose runtime. Now, let's take a look at how this presenter is created. API of molecule is very simple. There is either launch molecule, which returns state flow, or molecule flow, which returns flow. These two functions are entry points into molecule runtime, and basically from the scope of this function, you are able to create your own business logic, but with composable runtime. And this flow from molecule then be passed to composable function and collected as a state in a Jetpack Compose, in another runtime of Jetpack Compose. What did we achieve by this is that we separated logic from view. We get rid of need to define default values in a view, and now we are able to use reactive power of Compose in our presentation layer. And the thing is that Molecule doesn't even force us to use Jetpack Compose in the UI layer. It allows us to use any kind of view system, for example, in this example, that data binding. And Molecule is using only Compose runtime and its own wrapper around it. And for me, the interesting thing about Molecule is basically the simplicity of its implementation. When you will take a look at implementation, you will find around 3 files, which allows this magic to run. On this slide, you can see the simplified implementation of the Molecule, omitting few details, but basically this is the code which allows Molecule to run. On the first look, it may be hard to understand, but with a little bit of explanation and knowledge of Compose internals, it would start to make sense to you. And in case if you are interested in this topic more, I recommend you 2022 DroidCon talk, Demystifying Molecule, which is very interesting and is doing really deep dive into how Molecule works. Another and probably the most well-known example of usage of Compose outside of Android world is Compose multi-platform. It's quite a hot topic since Compose for iOS was moved to alpha stage recently, which, far as I understand, should mean that JetBrains thinks that this will be production ready once. And let's take a look at how it's implemented. Original Jetpack Compose code is already kind of written as multi-platform code with targets for desktop and Android. What JetBrains did is that they forked this project and added more multi-platform targets, such as web or iOS. And since it's forked project, the architecture is very similar to Jetpack Compose. It uses the most of the original code. And it's adding multi-platform targets to the original code. And basically creating a Compose multi-platform as we know it. Some parts of the Jetpack Compose code, which are Android specific, are left out. We will talk about it in a few slides. But for the most of the parts, it's using the same code as used in the Jetpack Compose. And let's take a look at some examples. So in honor of first public showcase of Compose, I recreated a bad jokes counter application. I'm not sure what was the second one, but the counter never lies. Anyway, this is implemented as Android application, but even when you will create multi-platform application from this code, it looks almost the same. And I think in order to understand how does it work, we need to take a look at how such project looks like. So let's take a look at how to make multi-platform application from this Android version. First, we need to create new project or just migrate existing ones to Kotlin multi-platform version. It's a quite new technology, but basically you need to create shared modules for each target platform and correctly set up your build Gradle files. In this case, for Android, iOS, and desktop. It's more complicated and it has more steps, but there is a bunch of articles, templates, and videos which helps you with this process. So let's move to next step. Now we need to extract Android-specific things to Android-specific module. This includes things like context, runtime permissions, toast, etc. Since these things are related to Android, it wouldn't work if they would be included in the multi-platform code. So you need to architecture your application carefully, like in order to be able to incorporate things like runtime permissions or toast. And then there are things like resources. R classes are also Android specific, so we won't be able to use them. However, Compose multi-platform brings its own experimental version for images and vectors. And as far as I know, the localization is not yet supported, and so you need to use third-party library, but hopefully it will be fixed or implemented somehow in the future. Now, we need to add Compose multi-platform dependencies. You need to remove old Jetpack Compose dependencies and add new Compose multi-platform dependencies and plugins to your Gradle files. It uses the same naming and almost the same modules as Jetpack Compose version. When I was looking at the multi-platform code multi-platform code of Compose for the first time, I thought that I will need to remove Android X Compose dependencies and replace it with multi-platform version, somehow like this. But that's the interesting thing. Even when you will be writing your application as multi-platform application only for iOS, you will still need to use Android X Compose package. It may looks a little bit weird, but this code will be used only within Kotlin code. So iOS developers may be calm. So and they do not have to fear that they will see Android X imports in their Swift files. And let's go to the last step and define code for multi-platform targets. In this case, Android, iOS, and desktop. But let's take a look at shared code first. The shared code looks the same way as it looked in Android-only version. Since we do not have to remove any Android-specific code, we are able to use same code without change. So let's take a look at how Android application with Compose multi-platform code looks like. The Android application looks the same way as Android developer would expect. The code is defined in its own module with all the files required to run the code as resources, as manifest, and shared code is imported from the share module. And this is sufficient to run the application. And that's basically it. Android application is running. The desktop application is created very similarly. This is a whole code needed in order to launch desktop version of the app, and both application window are implemented in a Compose multi-platform, so we don't need any other extra dependency. And again, the desktop code is defined in its own desktop app module, and Compose multi-platform component is important from shared code. And Compose multi-platform allows us to use some desktop-specific components or modifiers. This will probably be the case also for iOS or web. And in this case, we are able to detect pointer position on a screen and create hover effect when pointer is moved to the card location and moved out. Here we see the desktop version of the same app with our hover improvements. Again, you need to be careful about how to implement these things since pointer modifier is specific only to desktop. And currently, there is possibility to use them even in the common module, but the app won't compile on other platforms. So there is still some works to do. iOS version is basically the same thing, but it requires a little bit more of boilerplate code in order to get it work. Again, the iOS-specific code is implemented in the iOS app module, where we are able to use Swift code and all the things from iOS platform. We need to implement Compose UI View Controller, which allows us to embed Compose multi-platform code within Swift UI framework. And there we can import shared Compose code into this controller. And this is the power of Kotlin multi-platform on iOS with combination with Compose. We are able to embed Compose within SwiftUI, SwiftUI embed within Compose, and mix it this way. And this allows us to implement only some parts of the application in a Compose multi-platform and allow us to experiment with it or use it only for some specific parts of the application. And it works very similarly to Kotlin multi-platform, where you can only implement some parts of the application and skip others. And it works similarly as, I will describe it that it works similarly as native Android views that are working with Compose. You can embed one within another. And there we can see the result. Android-like application which is running on iOS. Like, it's hard to say how this technology will evolve in the future, if there will be more iOS-like components to get more native feel on the platform, or there will be using the same design as on Android. But the main thing is that integration within Kotlin multi-platform project is quite easy. And Compose multi-platform is currently in 1.4 version with Android and desktop in a stable state. And as most of you already know, iOS was recently moved to alpha, as I previously mentioned, and web implementation are still experimental. So Compose multi-platform is aiming to create easy-to-use UI framework, which is using existing elements of Kotlin multi-platform and Jetpack Compose to achieve this goal. For Android, it's using just the Jetpack Compose implementation, so most of the things internally works the same way. Other versions are using Skiko, which is Skia binding for Kotlin, which allows us to render composable nodes on a canvas for platforms such as iOS, desktop, or WebAssembly. And since Compose code is compiled the same way as Kotlin multi-platform code to native version or iOS, it has the potential to run very smoothly. And we are reaching the end of this talk, so let's summarize it. Compose runtime is very flexible and powerful tool. Composition and underlying implementation, such as snapshots, slot tables, are very powerful concepts. With custom implementation, we are able to use it as a tool for almost any kind of UI where we are able to use Kotlin. And as we saw, it can be even used without UI and take the advantages only from its reactivity for business logic, for example. Most well-known usage is probably Kotlin multi-platform, which may have a promising future, so it's good to keep an eye on it. And I would like to close this talk with one interesting thing. I found this on Twitter a long time ago, and I'm not sure who was the author, but I believe it was somebody from Jetpack Compose team, so hopefully I'm not spreading some kind of fake news here. But yeah, this was one of the proposals from possible Compose implementations. I believe that we are happy that it didn't end up this way, although Android developers would have easier way to become React developers. But on the other hand, the HTML version of the Compose would be much more easier to implement. Okay, thank you. And I believe now that there is a time for Q&A.
Thank you, Martin. That was really awesome and that was really interesting. I also fond of multi-platform, especially its side that interrupts with iOS development. So we have several questions. First, how to apply atomic design using Jetpack Compose?
Oh, can you repeat the question?
So perhaps that question was for our previous talk about atomic design to Jetpack Compose. So, next question was about molecule. What is the benefit of using it over not using it would be?
Sorry, I can see the question.
Yes. What are the benefits of using of molecular? You were speaking.
Molecule. Okay.
Yes, molecular.
Without using it, I would say I do not have a production experience with it, but would like to try that sometimes. And I think that the advantages are that you are able to use the reactivity of Compose. Yeah, we are mostly used to use this kind of reactivity in a Jetpack Compose application, but it's really interesting to try it with just business logic. Yeah, when you need to combine several flows together, it can get really complicated. But with Compose, we are able to do it in imperative steps, and that's kind of powerful, and the code may be much more readable.
Thank you. Yes, that was really interesting to know about this framework, because I think for many people, that was the first time they have heard about such technology. Because many people are using Jetpack Compose as something that almostly whole tool with whole sub plugins, and not something more. Is your team using multi-platform for anything in production?
Yeah, we started using Kotlin multi-platform several months ago on a few projects. Like, we started small, but we are going in direction to use it more and more, even if mainly for Android and iOS application, and we are trying to move the limit of it and try to find the right balance. But we are not using Compose multi-platform yet. It's still in the alpha, and I believe that there is still a lot of work to do before it will be production ready.
So, and in the cases when you use a multi-platform, what are the benefits of using it, and what are the most struggling places?
Most benefits are the our ability to share the code. Yeah, you are basically able to write one thing and use it on multiple platforms, and that's very promising. Like that previously, that were some systems you could use Java to Objective-C, you could use some kind of JavaScript, but this way you are able to use something that is really native to Android developers and just to migrate it in other platforms. And this is kind of powerful. You are basically reducing amount of the code, so you are also reducing amount of bugs and amount of needed maintenance on the project. And I would say that it's a relatively easy to do it. Yeah, if your team is on this track and believe that, hey, Kotlin multi-platform is right tool to do it, then you are able to migrate it. Like there are problems like setup of the project, and like to get the whole team to believe that this will work and solve some issues mainly on iOS. But when this is done, it can run very smoothly.
And what do you think about the improvements of this technology since it became the stable beta?
I'm really looking forward to it. Like when it was an alpha, there was some big changes. As we were experimenting with it, it didn't take us a lot of time to fix these changes. But as we are closing to, as we get to beta and we are closing to stable release, it's really important for us because we see that what we are using and the whole architecture that we are using won't be changed in the future. And it's also really strong message for clients. When we are talking with clients, it may seem like a risky movement to go into something that is alpha, but when it will be like a production ready and it will have a stable release, then it will be, I believe, that kind of different story.
You have shown us the sample that the potential improvements of Compose, where there will be such interesting tool to convert an XML to Compose code. And what do you think about the future of Compose multi-platform, especially Compose for iOS? And have you tried such tools as Redwood or something else as customizable frameworks to simplify the use of such technology with multi-platform, and using it with the Kotlin multi-platform without basic UI?
Yeah, I was looking at basically I was looking at the Compose multi-platform for iOS since I saw the first really experimental samples on Twitter. And it was DroidCon app written in Compose for iOS. which sound really interesting at the time. I was also looking at the Redwood implementation, and I haven't tried it yet. I was just looking at how it's implemented and how to use it, and that was also a really interesting concept. Yeah, and like I'm not sure if in the future will Compose multi-platform be better or Redwood will be better. Yeah, as far as I know, Redwood is still in experimental phase, and I'm not sure if they will plan to work on it more or not. And that's like really important. Yeah, when you will start to work with such technologies, it may be complicated to get back. Yeah, so but yeah, and the difference here is that Compose multi-platform is using is drawing and rendering their nodes directly on the canvas, and Redwood is doing something different. Redwood is using native views basically on an iOS to get the result. So similarly as we saw with the glance, yeah. So somewhere down there underneath all the layers, there will be Compose inflating Swift views, and this is like a different concept because if I would be explaining this to some iOS developer, I believe that this concept would be much better for him because yeah, we are using native interface. And there are like multiple questions if Compose multi-platform will be able to run smoothly, if it will able to handle accessibility the same way as native Swift UIs view do. So like, yeah, there are still a lot of questions. So I'm really not sure what will be future here.
Thank you very much. That was really interesting and awesome and deep dive into Compose as a paradigm and not only the Jetpack Compose or Compose multi-platform, but the whole conception. Thanks, Martin.
Thank you. Goodbye.